Hello friends, today we are going to find out the moisture content in the sample. Okay, so we have two samples in front of us. The first one is the pozzolana and then we have the biochar. So the moisture content of the soil is also referred to as the water content, that basically indicates the amount of water that is present in the solid sample or the soil sample, and it is the ratio of mass of water contained in the pore spaces, okay, of the soil to the solid mass of the particles in that material. Okay, and this is expressed as a percentage. So the standard temperature, that is 110 plus minus 5 degrees C, is used to compute the mass of the sample. And the practical applications is the soil test determine the inertial motion content of the soil, and it is very critical for all studies of soil mechanics, and it is one of the most important index properties that is used to correlate the soil behavior and its index properties, and is also used to express the phase relationship of water, air, solids present in the given sample, or the weight of material. And for cohesive soil, the consistency of a given soil along with its liquid and plastic limit is used to express its relative consistency. So the standard reference is the method, the method number is ASTM-D2216, and this is basically the standard test methods for laboratory determination of water, moisture content of soil, and rock by mass, that is based on the gravimetric analysis. The equipment is non-corrodable. You have to choose the vials or the cups that are non-corrodable, and there should be a temperature control drying oven that will maintain the temperature from 105 to onwards, and that should be thermostatically controlled. The balance, a sensitive balance, a container that you could handle the apparatus, and make sure that you clean and dry and weigh the container, weigh the sample. Okay, so let's start the experimentation of the tryouts. So the first step, I'm trying to dry the vial inside the oven for a few hours. So I've started the oven and we'll wait for a few minutes so that there is no moisture, no impurity in the vial. Then we will record the cool weight of the container. Now our containers are well dried. So first of all, let's take the weight of this container. So this weight is around 38.75 grams. Okay. This weight is around 39.66. First one was 38.81. So I put a tag here, 39.67. Now what I need to do, so I know the weight of the container. So I will take a specific amount of solid sample. So let's take around certain amount of biochar here, around 3 gram of the vegetable waste biochar. Also have taken the same amount of pozzolana, or you can say the volcanic ash. Now we need to dry these samples in the oven. Okay. Now to dry this specimen is to gain a constant weight, and we have to maintain the temperature that is from 105 to 115, and the time will vary with respect to the type of soil we are taking. So usually it is 16 to 24 hours. This is sufficient, and we have to record the final weight of the container with the dried soil sample. And usually for the peat and other organic soils, it should be dried at lower temperature, that is 60 degrees C, for a longer time. And usually the dry time for these samples, which are the soil based samples, is around 16 to 24 hours. So let us keep these samples in the preheat oven. We added the samples here. Let us close it, and then we'll come after 24 hours to check the final weight. So now after 24 hours, I will take out the sample and weigh it after cooling. Okay. So usually we should keep our samples in the desiccator for cooling. The weight of the can one is 40.70. and can 2 is around 41.80, and we already know the masses. Now weight of the water or the moisture in sample 1 is 40.70 minus 38.81. This is the weight of the, in terms of weight, so we can also calculate in terms of percentage by dividing by the mass of the the sample taken. Okay, so this is all about how you calculate the moisture content. It can also be calculated in terms of weight. It can also be calculated in terms of percentage.